Okay, for a second example of a system of nonlinear equations, I want to take this one, which is going to be a little bit more hairy, but it is going to give us an opportunity to check out the elimination method and how that works. Sorry, the addition method and how that works. So here I've got x squared plus 4y squared equals 16, and I've got x squared minus y squared equals 1. Now we've kind of got two strategies. We could try to cancel out the x squareds, which I could do by multiplying the second equation by -1, or we could try to cancel out the y squareds, which I could do by multiplying the second equation by 4. Both of those strategies would work. I'm going to go for the second one. I'm going to attempt to cancel out the y squareds by multiplying the second equation by 4. So I'm going to get 4x squared minus 4y squared equals 4. And then writing the first equation again, just so that we have them next to each other, we can add the columns. So it looks like I'm going to get 5x squared, it's a 5, y squareds will cancel out, and then equals 20. So dividing by 5, I have x squared is 4, and then I can take the square root of both sides. You can jump straight to the solution, although I'll take the opportunity to remind you that this simplifies as the absolute value of x equals 2, which means we have x is 2 or x is -2. So, as before, we now have two different paths that we need to follow down to their conclusion. We have to go back to one of our equations and say, well, if x is 2, what would y be? And then if x is -2, what would y be? So it doesn't matter which equation we use. I think I'm going to use the second one here. That second equation, if I rearrange it, I can get, let's add the y squared to both sides, and then let's subtract the 1. Let's get y squared equals x squared minus 1. Let's put it in that format. It gets pretty close to solving for y. All we've got to do is take a square root and get the plus and the minus option. So if x is 2, then y squared is 2 squared minus 1, which is going to be 3. So y, if we square root both sides, y is going to be y will be the square root of 3, or y will be the negative square root of 3. So that means we have solutions that we get from taking x is 2 paired with both square root of 3, and x is 2 paired with negative square root of 3 for y. So there's two solutions. But that's only one of the two cases. The other case is x equals -2, which, because we're squaring our y here, or rather because we're squaring our x here, it's going to work out exactly the same way, giving us 3, which is going to give us the plus or minus square root of 3. Whether you write them separately or together with a plus or minus, I don't really mind. I've done both here, so you can see that I'm okay with both of those. And then we have two more solutions from that possible pathway, which are the -2 root 3 solution and the -2 negative root 3 solution. So that's a little bit more hairy. We ended up with some square roots in our answers, which is fine. I'd rather you be writing square roots in your answers than trying to get decimal numbers, because with something like the square root of 3, which is an irrational number, you can't write it as a decimal expansion without truncating it or approximating it. And in general, I feel that exact solutions are better than approximate solutions if we can find them. Sometimes exact solutions are more difficult to find, and you have to settle for an approximate solution. But we don't have to do that here. So we have 4 different solutions to this system of equations. There we go.